Have you ever wondered if there exists a mirror image to our universe where everything is exactly opposite? Welcome to the enigmatic world of antimatter, often referred to as the mirror image of matter. Now, let's delve a little deeper into this mystery. Just as you have a reflection in the mirror, every particle of matter has a corresponding antiparticle. They are identical twins in terms of mass, but just like mirrored twins, they have opposite features. In this case, it's the electrical charge that's reversed. Imagine a particle of matter, say an electron, with a negative charge. Its antimatter counterpart, known as a positron, possesses an equal mass, but a positive charge. It's a fascinating concept, isn't it? This duality is one of the fundamental aspects of our universe, a testament to the brilliant complexity of nature. So if antimatter is just like matter, why don't we see it around us? In the Big Bang, matter and antimatter should have been created in equal amounts. But here's the twist. Where is all the antimatter? You see, our universe seems to have an overwhelming preference for matter, its playgrounds of galaxies, stars and planets, all composed of matter. This leaves us scratching our heads. Why not antimatter? Enter the detective of this story, charge parity violation. It's a theory suggesting that the laws of physics might not play fair. They might favor one twin over the other. Matter over antimatter. But how so? Well, it's like having a set of twins where one is left-handed and the other right-handed. They might seem identical, but their differences become apparent when you try to fit the left-handed twin's glove on the right-handed one. So, the universe might have a bias, choosing matter over antimatter. This imbalance between matter and antimatter is one of the biggest unsolved mysteries in science. While antimatter might be missing in the cosmos, we can and do produce it here on Earth. We dive into the world of high-energy physics, where laboratories like CERN, the European Organization for Nuclear Research, become the playground for creating antimatter. Here, scientists use particle accelerators to speed up particles to near light speed, then smash them together. This high-energy collision births pairs of matter and antimatter particles. For every particle of matter, there's an antiparticle, a mirror image with an opposite charge. When these matter and antimatter twins meet, they obliterate each other in a flash of energy. This is the concept of annihilation. It's a bit like the Eastern philosophical concept of yin and yang. They are opposing yet complementary forces, each consuming and giving birth to the other in a continuous cycle. In the case of matter and antimatter, it's an incredibly efficient cycle. The energy created from matter-antimatter interaction is staggeringly potent. To put it in perspective, it's millions of times more potent than chemical energy. Imagine the power of a single gram of matter meeting a gram of antimatter. The energy released would be equivalent to an atomic bomb. But don't worry, we're far from having that much antimatter at our disposal. In fact, this energy created from matter-antimatter interaction is millions of times more potent than chemical energy. We're just beginning to harness and understand this power. The journey is exciting and the possibilities endless. With such immense energy potential, could antimatter be the future of energy production? It's a tantalizing prospect. Imagine spaceships propelled by antimatter engines zipping across the cosmos at incredible speeds. Or think about medical advancements, where antimatter particles could be used to precisely target and destroy cancer cells. The possibilities seem endless, and the energy produced by antimatter is mind-bogglingly potent. However, like a double-edged sword, antimatter also presents considerable challenges. The first hurdle is storing this volatile substance. Antimatter has a rather explosive personality when it comes into contact with matter, making safe containment a challenging puzzle. Then, there's the cost. Currently, producing a single gram of antimatter would require roughly a year's worth of the world's total energy output. Yes, you heard that right. The price tag is astronomical. So, while the promise of antimatter is immense, so too are the obstacles that stand in our path. But let's not forget that throughout history, humans have shown an uncanny ability to overcome seemingly insurmountable challenges. As we continue to push the boundaries of our understanding and our capabilities, who knows what the future holds? So, while the story of antimatter is still unfolding, its enigmatic nature continues to captivate us all, pushing the boundaries of our understanding of the universe.